It came across the void, a faint whisper from Voyager 2, a signal so delicate it was almost lost in the endless static of space. For decades, Voyager 2 has been our silent ambassador, drifting farther from home than any human-made object before it, carrying with it the hopes and questions of an entire planet. The signal, traveling at the speed of light, reached Earth after nearly a day's journey, crossing billions of miles of emptiness to deliver its precious cargo of data. On a quiet morning in 2025, the Deep Space Network's massive antenna dishes turned their gaze skyward and received a transmission that confirmed a long-held fear. Voyager 2 had crossed another invisible boundary at the edge of our solar system, venturing into a realm no probe had ever fully explored. The data revealed that the edge isn't a clear line, but a chaotic, turbulent frontier where the sun's influence finally yields to the vastness of interstellar space. Here, the solar wind collides with the interstellar medium, creating a stormy borderland filled with cosmic energy and uncertainty. Voyager 2's instruments detected a dramatic shift in the cosmic winds, showing that the interstellar medium is not uniform, but pushes back, creating ripples, shocks, and invisible waves that buffet the tiny spacecraft as it presses onward. This wasn't a failure, but a revelation and a warning. The environment beyond our solar system is more hostile and unpredictable than we ever imagined, and Voyager 2's survival is a testament to both human ingenuity and the relentless forces of the cosmos. The probe, now over 13 billion miles away, faces a hostile environment that could silence it forever. Its power is fading, its instruments aging, and every new mile brings it closer to the unknown. Every new discovery brings both triumph and risk, as the spacecraft's aging systems are tested by the unknown. Each transmission could be its last, and every bit of data is a hard-won victory against the darkness. The engineers at NASA's Jet Propulsion Laboratory felt a familiar mix of excitement and anxiety. They watched their screens, knowing that each signal from Voyager 2 might be the final word from a distant traveler. They received precious data, but it came with a message. Voyager 2's final chapter would be its most perilous. The probe's endurance is a race against time, and every new reading is a reminder of its fragile existence. The probe's journey is a testament to human curiosity, but also a reminder of the dangers that await beyond our cosmic shoreline. It is a story of courage, risk, and the relentless pursuit of knowledge. We send our machines to the unknown, knowing each revelation could be their last. Yet, we press on, driven by the desire to understand what lies beyond the veil. The silence that follows may be the price of discovery, but it is also the echo of our greatest questions, carried into the endless night. To truly grasp the significance of this moment, we must journey back to the year 1977, when NASA embarked on an audacious mission, launching Voyager 1 and 2 on what was called the Grand Tour, a once-in-a-lifetime opportunity made possible by a rare planetary alignment that occurs only once every 176 years. Harnessing the gravitational pull of the giant planets, the Voyagers used gravity assists to slingshot from one world to the next, visiting Jupiter, Saturn, Uranus, and Neptune. These encounters unveiled breathtaking details of these distant worlds, transforming blurry points of light into vibrant, dynamic planets teeming with storms, rings, and moons. Voyager 2 in particular became the only spacecraft to ever visit Uranus and Neptune up close, sending back images and data that revolutionized our understanding of the mysterious outer solar system. After their historic planetary flybys, the Voyagers were propelled outward, their mission evolving beyond its original scope to become humanity's first attempt to reach the stars, our first interstellar scouts, venturing into the unknown. Their new objective was to reach the heliopause, the invisible boundary where the sun's solar wind finally gives way to the vastness of interstellar space, a frontier never before crossed by any human creation. Nearly 50 years after their launch, both probes have achieved this milestone. Voyager 1 crossed into interstellar space in 2012, followed by Voyager 2 in 2018, marking a new era in space exploration. Today they are the most distant human-made objects ever created, drifting more than 13 billion miles from Earth, far beyond the reach of any other spacecraft. Communicating with them is a feat in itself. A single command from Earth takes 19 hours to reach Voyager 2, and another 19 hours for its faint reply to return, a testament to the vastness of space. This immense distance is both a triumph of human achievement and a daunting challenge, pushing the boundaries of our technology and imagination, and defining the very limits of our reach into the cosmos. The Voyagers are true pioneers, sailing on an endless journey across the cosmic ocean, carrying with them the hopes and dreams of all humanity. Their remarkable endurance and continued operation are a testament to human ingenuity, perseverance, and our unyielding desire to explore. The Voyagers remind us that exploration is a voyage without end, and that our curiosity will always propel us toward the next great unknown. For Voyager, the greatest enemies are time and distance. These are not just abstract concepts, they are relentless, physical barriers that grow more formidable with every passing moment. Every second, Voyager 2 drifts 9 miles farther from Earth, stretching its fragile communication link to the very brink of possibility. The vastness of space is not empty. It's a chasm that tests the limits of our technology and our patience. Only the largest radio dishes on Earth, like the 70-meter antenna in Canberra, are powerful enough to reach Voyager 2 across the void. These massive structures are humanity's lifeline to a tiny probe billions of miles away. When that dish is offline, Earth is effectively muted, unable to send commands, only able to listen. For hours, sometimes longer, the spacecraft is on its own, isolated in the silence of interstellar space. If a crisis strikes during these blackouts, the team can only hope the spacecraft's autonomous systems prevail. There's no way to intervene, no quick fix, just anxious waiting and trust in decades-old engineering. The Voyager's computers are relics, with less power than a car key fob, battered by cosmic radiation for decades. Each year, the risk of failure grows and the margin for error shrinks. Parts fail, thrusters clog, and every command is a gamble, sent into the void with no real-time control. The team must anticipate problems before they happen, often relying on intuition and experience. The mission is a slow, nerve-wracking conversation with the past, each action based on predictions nearly 2 days old. By the time a signal arrives, the situation may have already changed. It's a testament to the challenge of managing a mission on the edge of forever, a story of persistence, ingenuity, and the unyielding human desire to reach beyond the horizon. Beyond distance and aging parts, Voyager faces a more fundamental threat: dwindling power. The spacecraft run on nuclear batteries, RTGs, that lose energy as their plutonium decays. Each year, the available power drops by about 4 watts, forcing tough choices. Engineers have shut down heaters and instruments, sacrificing science to keep the mission alive. In 2023, Voyager 2's plasma science instrument was powered down. In 2025, its low-energy particle detector followed. Each shutdown saves precious watts, extending the life of the remaining instruments. The team must decide which sensors are most vital for interstellar exploration. Turning off instruments means losing a complete picture, but it's a calculated sacrifice. The goal: keep at least 1 or 2 instruments running into the 2030s. Without these sacrifices, the Voyagers would already be silent. It's a delicate balance. Every watt counts in the battle for survival. Behind Voyager's longevity is a small dedicated team at NASA's Jet Propulsion Laboratory. These engineers are cosmic detectives, mastering antique technology and solving problems from 19 light hours away. When issues arise, they pore over decades-old manuals, run simulations, and craft commands with painstaking care. In 2025, they revived Voyager 1's dormant thrusters, a risky maneuver that saved the mission. Their ingenuity is routine. They've overcome garbled data, failing memory, and misaligned antennas. They operate on a shoestring power budget, rewriting the rulebook as they go. More than engineers, they are caretakers for humanity's farthest reach. Their dedication keeps the mission alive even as the spacecraft's power fades. The Voyager team's creativity is a masterclass in remote engineering. Their work ensures our legacy of exploration endures. Even as instruments go dark, Voyager 2's science is revolutionary. For the first time, we have direct measurements from interstellar space, revealing a turbulent, dynamic frontier. The probe acts as a weather station, measuring plasma, cosmic rays, and the interstellar wind. Its data shows the heliosphere is a complex shield protecting Earth from high-energy cosmic rays. Shutting down instruments teaches engineers how systems survive in deep space, informing future missions. Every day Voyager survives is a lesson in endurance and engineering. It teaches us about the universe and how to build explorers for the stars. Each Voyager carries a golden record, a gold-plated disc with sounds and images of Earth greetings in 55 languages and music from Bach to Chuck Berry. Conceived by Carl Sagan's team, it's a humble, hopeful portrait of humanity. The record says, "This is who we are. We hope to meet you in peace. The odds of it being found are infinitesimal. The Voyagers won't approach another star for 40,000 years, yet sending it was an act of hope. a belief that our story is worth telling. Even after the spacecraft falls silent, the golden record will drift through the galaxy for billions of years. It is a silent ambassador for Earth, a testament to our art, science, and dreams. The true audience may be ourselves, a reminder of our curiosity and optimism. It's a message in a bottle, cast into the cosmic sea. One day Voyager 2's final signal will fade, and its journey will continue in silence. This will not be a failure, but a quiet triumph, a legacy measured in discovery, not years. The Voyagers transformed distant planets into vibrant worlds and carried humanity's name farther than ever before. Their spirit lives on in every mission that dares to push the boundaries of possibility. They prove that curiosity and perseverance can overcome the vastness of space. Even after they fall silent, the Voyagers will carry their golden records toward distant stars. They are a permanent part of our story, an echo of our desire to explore. The voyage may end, but the inspiration will never fade.